Alright, so I have all the homework problems done out here. I'm going to try and go through each one of them. Probably the ones at the end rather quickly because they're similar to the ones before them. If you want to see 15, I already posted the video on that one, so we'll start with number 16. Okay. This is also a tangent graph, so we are still following these rules here, these notes that I posted yesterday. Knowing that it starts at negative pi over 2 being an asymptote and goes over here to an asymptote at pi over 2. The other thing that's important to know with this on the parent function is that this point's normally at negative 1, our intercept, and then here at 1. The thing that will change these values, okay, are the d value might shift that up or down, okay, and also the a value will stretch these vertically. So the second key point here is going to be negative, and the fourth key point is going to be that positive value. If we were to have a negative out in front of our graph, that is what's going to switch those. Okay? So this one is now going to be the positive value, and this one will be the negative. But we're going to follow this process of finding the period, the distance in between each key point, as well as finding our endpoints here, and then coming up with our other key points. Pretty similar to how we did with the sine and cosine graphs. So for number 16, I started by finding the period. Okay. Our period here is pi. Okay, if we did pi over b, there is no b value here, so our period would just be pi. I forgot to write in here the key point, the distance from key points. Okay. That we're going to do the same way, is take the period and divide it by 4. Okay, so we get pi over 4 here. So to find our starting point, again, using these endpoints here, if I set my starting point bx minus c equals negative pi over 2, here basically my bx minus c is just an x. So x equals negative pi over 2 would be the start, and bx minus c, which is just x, equals pi over 2 is going to be the endpoint. You can see here that from each of these values, I'm adding pi over 4 to get to the next point. Okay, kind of similar to how we did with our previous trig functions. I know that this here is going to be 1/2. Okay. Normally that is the negative value, but because we have this here, it is going to flip. Okay. So that is now going to be the positive value, and this is going to be the negative value. So instead of our normal tangent graph like this one up here, this shape, it is now going to be this shape here. Okay. Again, this a value out in front kind of works like our amplitude. That tells us that this point is going to be up 1/2 from the center of our graph, and this one's going to be down 1/2 from the center. Okay. So I put those points on here, knowing that these the start and the end are going to be the asymptotes, and coming up with these y values based off of the other parts of my function. Okay. Once I put those on here, then I can continue that same pattern to come up with that second period of the graph. If we now look at go to 19. Okay, number 19, I think that was the next one. Okay. Number 19 here, okay. I'd first start by finding the period, okay, which if we do pi over our b value of 3, our period is going to be pi over 3. And our distance between key points, if we divide that period by 4, we know the distance is now going to be pi over 12. Next, to find my starting point, set that bx minus c equal to negative pi over 2. So we just have 3x equals negative pi over 2. To find our starting point to be negative pi over 6. And same thing for our endpoint, setting it equal to pi over 2 to get this endpoint at pi over 6. Okay. Again, we know that those are going to be our vertical asymptotes. Okay. Then we look at these other key points. Okay. We do that by adding pi over 12 to each of these to find the x values. And then thinking about our y's. Okay. This is normally at negative 1, but because we have this a value of negative 2, it is now going to make it positive and move it up to 2. Okay. This intercept value doesn't change. Really the only way that can change is by adding in a d value. That's the only one that will shift the center of your graph. And then this one here is now going to be negative. Again, we are going to have this opposite shape here. I should have made these a little more curved. It should come down a little more, come into the axis, kind of like they are down here. So now that we have these 5 key points, we can put those in here on our graph and then continue with a second period here. Number 20, this one might look a little different because we have a pi in here as our b value. We still do it the same way. We do pi over b, so pi over pi, the period would just be 1. Okay, then our key points, we divide that period by 4 and we get 1/4. Now when we go to find the start of our graph, we do the same thing, bx equals negative pi over 2. And when we divide that by pi, we get our starting point is at negative 1/2. Knowing that our tangent graph always starts with a vertical asymptote, we know negative 1/2 is going to be a vertical asymptote. Same thing on this side here, setting it equal to pi over 2. Okay. Basically just following these rules here, all right, that I wrote on our notes, finding the end and start points, and then working to find the 4 key points in between. Okay. Knowing it goes up by 1/4, we can find these 3 points. Okay. Again, this one is also going to flip over the axis, okay, which is now going to make this point of -3 come up to +3, and the one over here at positive come down to negative. And again, we can just do that for 2 periods here. That's what the book asked for 2 periods of the graph. All right, and from there we went on to number 27. Okay. I tried to give you the homework, just the tangent and cotangent ones for this part. The next homework assignment will be secant and cosecant. Number 27, okay, to do our period, pi over b, pi over 2, and then again our key points dividing by 4. Again, doing the same thing to find the start of our graph, bx minus c equals 0, bx minus c equals pi. Okay, the difference with this one, this is a cotangent graph, so looking back at our notes, instead of using negative pi over 2 and pi over 2, the cotangent graph is going to use 0 and pi. Other than that, it's essentially the same graph, although these values are also flip-flopped. In the tangent, that's a -1, and that's a +1. Now the cotangent is flipped. So now that I have my start and end points, I'm going to do the same thing, adding by pi over 8 each time to get my points. This 3 tells me that these points are going to go up to 3 and down to -3, as you can see in my graph here. I put those points on here and continue with the next period. Number 28, also a cotangent graph. This one might have been a little more difficult just because we have the pi over 2 in here as our b value. Okay. So when we come up with our period, pi divided by pi over 2, if you multiply by the reciprocal there, we get 2 as our period. Dividing the period by 4, we would get 2 over 4 to get our key points. 2 over 4 is 1/2. Okay. Again, the same process here to come up with our 5 key points on our first period. Knowing that they go up by 1/2 each time, and that these points are now going to be at 3 and -3, just looking at our a value, we can come up with this graph here. Okay. It's okay if you did another period this way, or you started with one to the negative. It just asks for 2 periods. This shape is going to continue to repeat itself. So just 2 more problems here. Number 29. Okay, this is back to a tangent graph. Okay. It's important to know that our tangent graph, I guess I should have put this on the notes here, but our usual tangent graph has asymptote, and then it's going to be this shape, and then an asymptote. Okay, continuing that. Okay. While our cotangent graph is going to be the flipped version of that. It is going to, oh, that should be an asymptote. It's going to come down this way. Okay. Basically the reverse graph of the tangent. All right, so for this tangent graph here, again, taking the period, taking pi and dividing by b to find our period, finding the key points by dividing the period by 4. Okay, I think this one should be pretty easy because Our key points are just going up by 1 each time. So we're starting at -2 and going up to +2, 2 vertical asymptotes. There is no A value out in front here, so that makes these pretty easy. They're just going to be -1, 0, and 1, just like the parent function. So this is what our graph should look like here. And then for number 30, again, taking pi and dividing by 4 to find the period, and dividing the period by 4 to find our key points. So key points should be going up by pi over 16, and -pi over 8, and then -pi over 16, 0, pi over 16, pi over 8. That helps you figure out your values on your x-axis going up by pi over 16 each time. Again, no A value out in front here should make it easy for you to come up with these points here. For this homework, there were no C values in any of those graphs. We're going to do those eventually towards the end of this week. I will post all the answers, basically this whole homework sheet. I'll post this on Google Classroom for you to take a look at.